Okay, this is problem number 14, plus I have one additional bonus, more challenging problem on here. But this is perhaps maybe the most important problem in general for the entire first semester. This is something we want to be really, really strong on. And stick around even if you think you know it, or you can fast forward, zoom forward to the example problem. But here we're given a function that maps out to be this graph, just some function. We don't know what equation make this happen. This looks like it might have to be a piecewise function in order for that to happen. Doesn't matter. This is the graph of y equals f of x. So we're to find y equals f of x minus 1. So back to the the, the pre-function post-function aspect. We know what f of x looks like, but minus 1 is a post function. So I put x into f, and I get out my height, or f of x. This is my height. And then I have a simple little function here that just subtracts 1 from the height. So what do I end up with is this height minus 1. So every point is just readjusted with height down 1. So down 1, down 1, down 1, and down 1. And if I plot in those points, connect the dots, I've got a function that is 1 lower than f. So nice little concept. Post function will affect the height. I put in time, I adjust time into a height, and I subtract 1 from the height. Post functions are really simple to deal with. Takes maybe a little more thought on pre-functions. Such as, here is a pre-function. And you can do this by myvox, and that's all right. That's most interesting value of x, myvox. The most interesting value of x is typically, we'll refer to that, what makes inside of parentheses become 0. That's negative 1, which implies a shift to the left of 1. But that's kind of like memorizing a rule. How about this? We know we have a pre-function. We're going to choose x, we're going to add 1 to it, and we get out x plus 1. This is time. This is adjusted time. And then that we take our adjusted time, then we go in. So this is pre-function. We are adjusting time. How about we think about this in terms of time? Days, height, inches. So we're going to think of this as a 1-day head start. 1-day head start. So if it took my corn 3 days to get to this height, and it had a 1-day head start, that would mean we'd start from here, go to there, and we're actually moving back 1. 1-day head start, everything happens 1 day sooner. So this point would happen over here. This point would happen over here. This would occur 1 day sooner, 1 day sooner. I really like the idea of these addition subtractions either being 1 day head start, or if it was subtraction, 1 day delay. That has a lot more meaning real world. It's a 1 day head start. Oh, x plus 1. I get credited with 1 extra day of growth. Okay? I'm ahead of time. Things happen before. Whereas I would call this the 1 day delay. What used to happen on day 4, if I'm delayed a day, happens at day 5. Or if my plane was supposed to arrive at 10 o'clock and it's delayed an hour, it happens an hour later, 11. Or if it took 3 days for my corn to get to right here, it takes 1 more day, 1 more day, 1 more day, 1 more day. Now, I get it. myvox works for us. Our myvox is 1, or positive 1, which implies a shift to the right of 1. But I hope you're taking time to think, 1 day delay. I really think that's going to help us out. 1 day delay, what happens at day 0 now doesn't happen until day 1. I can't start till we get to day 1. 1 day delay. All right, we got two things going on here. I'm just going to order of operations this. We have a 2 day delay, and then we turn that into a height, and then we take the opposite height. So my 2 day delay takes me to here, 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 and there. That's where we are. So that's our 2 day delay. Let me color code this. Now we're going to turn that into a height. We've got our heights up there in red, but now I want the opposite height. So the opposite height from this point, the opposite of up 4, down 4, the opposite of up 3, down 3, the opposite of up 0, down 0, and the opposite of down 1, up 1. So there is our, follow this point, to the right 2, upside down, to the right 2, upside down, to the right 2, upside down, and to the right 2, upside down. There is our new function. So new function, I'll draw that one in green, is this guy to this guy. I already had it drawn. Of course, you caught me, didn't you? I already had it drawn. Down here. Whew. Escaped me just for a moment. Don't have to be smart to do this job. So there's a 2 day delay upside down. Okay, this one. This is one that I've seen people just guess at. Like, oh, I remember this one. I remember there's a rule about f of negative x. I just don't remember. Does it flip over the x-axis, flip over the y-axis? Well, if we understand pre-function, post-function, it's a breeze. I choose x. I put it into a pre-function, which basically multiplies by -1. So this is time. This is adjusted time, which we then put into our basic function and then turn it into a height. So this is a pre-function. It affects the time. This makes time go backwards. What used to be to the right is now to the left. What used to be to the right over here is now to the left. What used to be to the right 0 is now left 0. Right 1 is left 1. And right 3 is left 3. So we end up with this. And I say, oh, I see. It's that this is the one that reflects over the y-axis. I would hate to have to memorize that, and I suspect that if you were doing this type of thing last year, some of you probably forgot which way this reflects because there was no vision. We couldn't see it. So opposite time, time right, left. Oh, the opposite right, left. Okay, isn't that simple? Not something you're going to forget. Pre-function or post-function, I'm going to ask you all the time. I'm multiplying by 1/2 after I've converted to height. I'm multiplying the height by 1/2, and that's all I'm doing. This is just half the height. It's not going to change the x values. I'm not adjusting time. I'm still going to have significant defining points on those x values. I'm just going to have half the height at those. So half the height here, half of 4, 2, half of 3, 1/2, half of 0, 0, and half of -1, -1/2. Half as tall. Love post functions. Not much thinking involved on post functions. Pre-functions, however, this is huge. I suspect a lot of people intuitively would make this graph twice as wide. When you have a pre-function multiplier, you want to use the words as fast. In this case, twice as fast. 2 times as fast. So 2 times as fast. Think before you speak out. Clearly this is pre-function affects the time. Does 2 times as fast mean twice as wide? Well, if things happen 2 times as fast and they typically happen in 4 days, what would be twice as fast as 4 days? 8 days or 2 days? 2 days, twice as fast as 4 days. So everything happens twice as fast. 4 goes to 2. Twice as fast is half as wide. So twice as fast as to -2 is going to pull into -1. Twice as fast as 0 here. Twice as fast as 1 would happen in a half a day, and twice as fast as 3 would happen in a day and a half. That is not necessarily intuitive and certainly the opposite of how we'd memorize. And I know some people have actually memorized these rules this way. Well, if it's, and they don't even talk about pre-function, post-function. If it's inside the parentheses, just do backwards of what you think it should be. What a lousy way to understand math. That is total trained algebra chimpanzee, and that will fail you down the road. We're not going to memorize rules that don't make sense to us. Okay, here's the big giant bonus problem. I'm going to take each of these steps. First, this is going to take us to the right 3. This is going to take us twice as tall. This is going to make us upside down. And this is going to take us up 2. So I'm going to take this point right here, going to start right here, and I'm going to go to the right 3. 1, 2, 3. And then I'm going to go ahead and I'm going to make it twice as tall. What was 3 becomes 4, 5, 6. And now I'm going to make that upside down. What was up 6 is now down. 1, 2, 3, 4, 5, 6. I'm just here as an X now still. And now I'm going to take it up 2. 1, 2, and I think I'll use blue for that. There's my final point. I'm going to start with the next point. And I'm going to take it to the right 3. 1, 2, 3. I'm right here. I'm going to take it twice as tall. Uh-oh, did I go up? 1, 2, 3, 4. Should have been up back here. I'm sorry. Twice as tall. I was at 4. Twice as tall. 8. Down to -1, 2, 3, 4, 5, 6, 7, 8. 1 off my screen. And up to 1, 2. I'm actually right here. My apologies. I don't think I'm going to restart this video. So appreciate that. Let's go back to this point now. I'm going to go to the right 3. 1, 2, 3. I'm going to go twice as tall from 3 up to 6. I'm going to go upside down. 1, 2, 3, 4, 5, 6. -6. And then I'm going to go up 2. 1, 2. Okay, so my list of instructions would be right 3, 2 times as tall, upside down, up 2. Okay, that might not be a bad idea to list that out. So I'm going to go to the right 3. 1 from here. 1, 2, 3. I'm going to go twice as tall of 0, 0. I'm going to go upside down, 0, 0. And I'm going to go up 2. 1, 2. Okay, so I've got this point, 1 more. From here, right 3, 1, 2, 3. I'm going to go twice as tall of -1, -2. I'm going to go upside down, +2. And I'm going to go up 2, 1, 2. So I end up with a point here. And there we have our graph that is 3 to the right, twice as tall, upside down, up 2. So a lot going on there. You can break it down into bit-by-bit component and just handle each point separately. Hope that's helpful to you. That is something I'm going to strongly recommend you be very, very good at.